first off, thanks everybody for coming to this. This is the first in our new Field to Future webinar series that we're doing at Tosi. Some of you may have noticed if you've looked at LinkedIn today that Tosi Box has now become Tosi. And we'll kind of be diving into that briefly. And really, part of this webinar series is bringing in other technology partners. The reason for the name change to Tosi was when we started in 2011, we were a remote access company with a box that we called a lock and keys. And it built secure VPN infrastructure and added firewalls and cybersecurity, but it was really honed in on remote access. Since 2011, we've drastically grown into full-scale critical infrastructure, OT cybersecurity, and networking. And that encompasses a lot of different applications, as a lot of people are aware of whenever you're trying to find the best solution of how do I get my data from the field? How do I secure it and get it to a hosted SCADA application or historian or a building management system? What happens when I lose comms? How do I increase my data efficiency? How do I protect that environment? Um, are there other applications I can tie in that are specifically tailored to what I'm trying to do? There's so many different platforms out there. There are a lot of them out there. And the reason we really wanted to bring AUTOSOL on as the first group that we brought into this Field to Future webinar series was because we worked so well with them, and this is the space that they play in. So I'm very, very excited to have Andrew and Cody on. We talk all of the time about different applications, but with that being said, I'm gonna kick it over to Andrew and kind of let you introduce yourself to the group, and then we'll go to Cody.
Well, thanks for having us, DJ. So my name is Andrew Hinz. I'm the Senior Manager of Digital Operations at AUTOSOL. My background has been in automation and field area networks, all things on the edge, for about the past 23 years, and been in oil and gas, primarily upstream and midstream, for the past 12 years.
Yeah.
Awesome.
I'm Cody Pannell, Director of Software Development here at AUTOSOL. Grew up around the oil and gas industry my entire life. My dad was an operator growing up. Went to school for computer engineering and started at AUTOSOL right after that. Started as a integrator, providing HMI solutions, and then switched over to development about 8 years ago, and focused on our Edge product since then.
Awesome. Awesome. Well, with that, first off, what is AUTOSOL? Like, what is AUTOSOL as a company? What do you do? What is y'all's focus?
Yeah, so I'll take that. Primarily in the energy vertical, where you have remote operations or you have lots of devices that you need to pull. So essentially, AutoSol, they've been around since the late 80s. Cody can correct me if I'm wrong, and have been in the space where it's a polling engine and protocol conversion, whether that's server-based or edge-based, and that's where we fit. When you need to talk to many devices that are of different makes and models and different communications infrastructure, AutoSol is the shop to for that polling infrastructure to feed SCADA historians and such.
Yeah, so basically, I mean, we run into this a lot, but you have customers, especially acquisition mode companies, in the upstream space or midstream space even. It's happening a lot right now, actually, but is you may acquire a field. Most of your field assets may all be Rockwell or Siemens or Schneider or ABB. You might be using all ABB total flows across most of your infrastructure. You buy a new field, completely different system, completely different protocol than what you're traditionally using. That's a huge win, or a huge piece of where to use AUTOSOL in those applications is you want to pull that data into your SCADA system. It works seamlessly with all of these different protocols to try and make one unified space. Right?
Yeah, Yeah, that's what's going on. So over the last, traditionally the model was that SCADA was the polling, and SCADA would talk to all your devices out in the field. And then on the back end behind SCADA, it would provide information to your historian or those business applications that needed data. And what has been occurring, I mean, just even in the last 2 years, is that you've seen all these companies, they've acquired other businesses, especially in oil and gas, where they bought different fields and they've been operating as different independent business units. They have their own SCADA, own historian, they've been letting them run. And Cody, I would love to hear your opinion on the matter if you're seeing the same things. But in the past 24 months, what I've seen is the consolidation of these. Instead of having running 4 or 5 different separate SCADAs with 4 or 5 different companies, what we're seeing is that we want to get all this under one enterprise SCADA, and we need to bring all this data in from the field, whether that is from total flows, whether it's from rocks, whether it's a Rockwell, Siemens. You have this big melting pot of different technologies, and how do we scale this and talk to everything and make it simple? Well, SCADAs are extremely powerful, but necessarily not the best polling engines. So what AutoSol allows you to do is to bring a lot of devices all on at once, whether that's from a server, from an edge. A lot of the organizations I see are doing a hybrid. We want high frequency data, or we just need to pull something once an hour between, measurement or SCADA data, or to feed the Pi teams or what are those other things are. So we see this, it's the redoing of network architectures to bring it all under one fold, and that's where AutoSol's sweet spot is. Cody, what do you think? What's your answer to that?
Yeah, absolutely. We've seen a lot of customers who have taken the approach to get more out of the data that they're already gathering, and to try and gather more data without having to redo their entire networking backbone. So yeah, they're focusing more on standardizing the data. What's real big with our customers is coming up with a unified namespace, fitting all of their different fields into a similar ecosystem so that it's easy to use that data in order to improve their processes and increase their production through that way.
And actually, that's a good segue in. Can you pull up that first slide?
Yeah.
And it's the reasons why are we doing this? Okay, why do we want to standardize? Why do we want to bring in faster data? So you have a lot of organizations that absolutely they have made investment or they want to use leverage machine learning AI. And I'll use that loosely. This is not that type of conversation. But to use machine learning and AI effectively, traditionally in polling, it's been 15-minute data. Okay. That is not enough data to do an analysis and make a decision off of for optimization for machine learning and AI applications. They want lots of data and they want it at the highest resolution possible. The more data that you can provide those models, the better that they're going to be. So this is why AutoSol is in the mix, because what Cody said, we're standardizing this and we can get into the contextualization and unified namespace. Cody knows more about that than I do, but they're standardizing and they can bring the data in at a higher resolution, or provide more normalcy or contextualization to it so they can start to feed these models and see, make money, save money, improve efficiencies, etc.
And on the efficiency side, and this may be something that we're about to get into, but MQTT is a massive buzzword in the space. Massive. Um, can you kind of dive into why someone would go from a Modbus or an OPC and just convert to an MQTT as a whole? My main experience with it has been it drastically, whenever you change to MQTT, it's a a publish and subscribe protocol versus a polling constantly chewing up data on a sensor or a tank level that's never changed. The tank level's been the same for 6 months and you're still polling it every 5 minutes. Versus I only want notification or only want data if it actually changes. But can you kind of dive into a little bit more on the MQTT side?
I'll let Cody field that one. And then
Yeah,
I'll
absolutely.
Yeah.
Yeah, from a protocol point of view, people are switching to MQTT mostly because of that pub sub as an alternative to poll response. and the bandwidth savings that they're going to see from it. With MQTT, you can leverage report by exception, so you are only sending the data that changes. We did a comparison a few years ago when we first started building MQTT into our product, comparing it to Modbus, polling real-time tags. And the thing with Modbus is if you're polling 1,000 tags, even if only 10 of them have changed, you have to ask for all 1,000 tags and have them all sent back up to you. With MQTT, that's not the case. You can poll at the edge and then publish just what has changed, which leads to drastic bandwidth savings. We saw with even 50% of the data changing on every poll, there was still, I believe it was like 95 or 96% decrease in bandwidth, and that's down to the basic level of the protocol, the way MQTT is designed. It's designed for these low bandwidth networks, low latency networks, where you're not going to get a ton of data through there. So it really shines in our industry for that reason. On top of that, people, since you usually have to have something converting the native protocol to MQTT, another reason people like it is because there's typically room on that device that's doing the protocol conversion to buffer the data. So if you do lose communications, which happens, fairly often, for some of our customers at their remote sites, we can just sit there and buffer the data on the edge and send that data back up. The graph that's actually shown on the screen right now is one of our customers. They were polling ROC devices over like a 900 megahertz radio it was about 1,200 tags from them, and they were only able to pull those devices once every hour. Once they put something like Edge ACM out there, they were able to drop that down to 1 minute and get 60 times as much data resolution through these devices or through their network without having to change out anything else.
That's pretty awesome. So, okay, that makes a lot of sense. I guess another question is on what is AUTOSOL's tech stack? Is it specifically moving things to the edge? Is that probably the best way to increase efficiency on data, or is there also the ACM module itself hosted in the cloud? Would that be something I'm thinking of in the realm of like Ignition as your SCADA system, and they may have drivers, right?
Mm-hmm.
AutoSol, from what I've heard, is a lot more efficient as the driver in the polling engine, right? But can you kind of explain the two different products or other products that I may not be aware of actually?
Yeah. So ACM's our flagship product. It's been around for in some version over 30 years, right? We started doing protocol conversion back in the early 90s. At that time, it was called aux, and then it turned into AES, and now it's in its third iteration called ACM. The challenges then were a little different. So ACM is built to solve different problems than Edge is currently. So ACM is a server-side application. Traditionally, it sits typically right next to your HMI on the same server. And it's reaching across these same networks to get data from their devices. Where ACM really shines is we have a ton of functionality and capabilities built in handling. If we get an incomplete message back in a certain protocol, we know how to handle that properly without losing all of the data or having to restart from an initial connection. We have a lot of logic around controlling the finer details around your communication to a serial device. We can interleave different protocols on the same connection so that you don't have to, if you have a serial network out there with both Modbus and ROC devices, you don't have to worry about juggling two different connections to that serial network. So ACM, as it grew as a product, faced those challenges and has a lot of that capability built into it or baked into it over the decades.
Okay. And then Edge ACM on the other side.
Yeah. So Edge ACM, we started about 8 years ago when kind of edge computing was starting to take off. So there weren't many devices that had a Linux operating system on them, but now there's a whole array of them today that are available today that are industrialized. And it became more of the well, we don't want to really go out and replace the entire radio networks or cellular networks that these devices are on, but we do want to get more data. This is all about the same time that AI and machine learning conversations were starting. So it became, how can we get more data without increasing the size of our data pipeline or communication pipeline? And it's the obvious answer was MQTT. So we took the same protocols that we've always been doing, moved them to run in a lightweight Linux environment, and then converted them to MQTT to send that data up.
Awesome. Okay. So I mean, I guess in y'all's experience so far, it seems like a lot of data is moving to the edge. Is there still a solid mixture of both where would you utilize both of those applications in the same network, or is it more of an all or one?
No. From what I've seen in the multiple customers, I've only had one that went to an exclusively all edge strategy. Most of the networks that we see or that I've seen have been a hybrid. Okay. And going to your point, hey, I only need to talk to this thing once an hour, but I don't want to pull it once an hour. I want to leverage MQTT. I want to put a small edge, excuse me. I just need to pull it. But again, I'm cleaning up my network. So instead of SCADA trying to reach out to all these devices, they're using ACM server base to reach to these things once an hour, for example, because it's not going to change that fast, and then be an OPC connection from ACM to your SCADA system. Have an OPC connection from your historian or your FlowCal, etc. And then it moves down to, well, hey, on these locations, I want to leverage MQTT, and there's multiple things I want to do. Now, I'll leave this as a good point. Edge computing is, don't think of edge computing as a one-trick pony. Every time I want to do one thing, I need to have a box to do that. That is old school thinking, and the industry is absolutely getting away with that. 7, 8 years ago, when you had some smaller devices, and let's say they weren't as robust and they were running Windows, you didn't want to do that. Now people are taking advantage of Linux. Processors are there. The boxes are much more robust. I mean, I have favorites and I have ones that I wouldn't put out in the field because they're going to be bug hunting every 6 months. And but you could have the horsepower to run multiple things. Now, when I was when I did field things as an integrator, it was, hey, go touch these 1,000 locations in year one. And then a year and a half later, hey, we have a new thing that we want to do. We got to go retouch those sites. Now with edge computing, you land it once. It has enough horsepower to do your future things, or you can interchange. Hey, I don't like this piece of software. I'm going to unplug this and land this. And as long as your communications infrastructure is there, you can deploy these things very simply. So again, look at edge computing, and this is why we're on the phone with you, DJ, and we collaborated, is that on the same box, you can run Tosi, you can run EACM, run Docker and then put a container of EACM. You can run Node-RED, or let's say you have the optimization container, or let's say there's something else that you want to do, you can do that all on one box. That's where the industry is coming to. You're cleaning it up, you're future-proofing yourself, and you're putting that horsepower where it's needed, and you're simplifying it. I only have to manage one box, because when you do have the mentality of every box needs a thing, and I need to go out there in another year, you got to think of it this way. It's just not land in another box. I need to talk to it, so maybe I need to put in another switch, or I need to do some IT things. Maybe I need to add additional radio. I need a place in the panel to put it. And I also need a way to power it, because a lot of these sites where people want to take advantage of edge, it's 2 batteries and a 300-watt solar panel, and you can't have multiple boxes there. You're constrained. So if I can land one box doing multiple things on it from a software perspective, that's the way that because companies are going.
Yeah. Yeah. Another question on that is, especially with these like really remote scenarios, but it's a really lightweight application. I'm just thinking of like maybe some just basic sensor data that's out in the field, or maybe there's a pad site or an area for a company that has 50 pads, 50 well pads. Are you seeing that they're putting an edge compute node, even if it's a lightweight one, like the Emerson node that I've seen y'all use, even if it's a lightweight one, are they putting one at every single site, or are they maybe tying 10 of those sites, almost like a master sub scenario, where they're tying 10 of those sites to one edge compute node, that they may be running multiple applications on that to control multiple sites instead of having to make the expense of deploying at every single site in their infrastructure.
Yes, yes. So you could place that, and it's a hub and spoke model. Okay, you have the slaves, which are then going to a master tower, which is EACM can talk to those devices. Let's say it's got 20 pads or 30 pads hanging off of a tower, for example. Talk Modbus, go to that tower, and then spit out MQTT. And
Mhm.
we have enough storage on there, so you can store and forward. You can save 5 days worth of data, send it out, and you can backfill and stuff. And that's, without getting into the weeds, it's not everything needs to be far edge or everything needs to be server based. You can be at the middle, right there. Again, put it at a master tower and then go off to the slaves.
Yeah. The store and forward piece has been increasingly more interesting or intriguing with customers, especially when it comes to comm loss. I mean, the reality is we're in remote areas. Verizon may be the only carrier in that area, and if that Verizon tower goes down for 12 hours, well, you just lost 12 hours worth of data.
Hmm.
Normally, the comm loss period is an issue because you may need the comm loss because your SCADA is running that specific application. And when you lose comms, you need to shut it down. But in a lot of scenarios, it's just basically the loss of data. That's the biggest headache. Is EACM is something that's fully capable of storing that data, as you just kind of said. I mean, if it was 5 days, you can store 5 days. Is there a limit or a frame on that, or is that specifically based on compute?
Cody, you can handle that one.
Yeah, it's going to be based on a couple things. So it's going to be based on, yeah, the size of the device that you have out there and how much memory it has. And then it's going to be based on how many tags that you're actually pulling from each device and then at what rate that they're changing to. Um, so we do have it built into our application, a little calculator that you can pull up and you can put in, it'll scan how much device or room you want to allocate on the device for backfill data. And then it'll say how many tags you have and you can put in about what you think their estimated rate of change is, and it'll tell you how much space you actually have in terms of days. You would be able to go offline and keep that backfilled data.
Okay, awesome. Well, I know we're getting somewhat close, we got a little bit more time, but I did want to kind of dive into where the layout image that we were kind of looking at before and kind of start diving into where does this solution traditionally fit. We've kind of already covered some of those points, but really dive a little bit deeper into the scope.
Yeah, go into that third slide. I think that'll be good. Let me make sure it's that correct one. So if you can advance it. Not that one. Go past this. Yeah, right there. So
Okay.
this is an example of kind of what is going on and people have to deal with on a real world basis. So the red, what you see is measurement data, and the blue is real time data. And you can see where AUTOSOL fits, is that we have AUTOSOL as a server base that is talking to those measurement devices and then providing the EFM records going to FlowCal, going to SCADA, going to your historian and such. And then the blue is where you'd have on the left-hand side, you have an edge box, it goes to a broker, and then fits where maybe you have contextualization, you're feeding it into the cloud. But this is where we see the simplification, where FlowCal might be reaching out to a device. Your SCADA system is reaching out to a device. Pi is reaching out to a device. I'm going to use this as an example. FlowCal needs 1 hour data. It reaches out. It's talking to the same device that SCADA is talking to, where it wants gases at 5 minutes and it wants liquids at 5 seconds. And then the historian folks, they get it whenever they want, what they want to do with it. So again, in the simplification of this, AutoSol is the polling engine, and they're all sharing in that data. Where we see where SCADA was in the data business, now they necessarily don't want the measurement folks or the Pi folks coming to them and saying, hey, can I have some data? Can I have these hooks? And so you're having these departments that may have been 20 people 4 years ago, and now they're down to 5 or 4. There can be a lot more efficient. And using AutoSol, it is that polling engine, and then you can have your SCADA, Pi, Flocal attached to AutoSol to provide that information for you.
Okay. So is the AutoSol polling engine, I'm still trying to wrap my head. Is that specific in this example? Is that ACM? And is it
Yes.
riding on like a server, an edge server? Okay.
Yeah.
Yes, we have a couple different options. So like if you look at the left side where it says AutoSol in the box that's out sitting
Mhm.
between like the RTUs and your network device, that would be where Edge ACM sits close to the devices, and then publishing up to MQTT to a broker, which we have represented by Hive there. And then we have ACM sitting in the box where the red lines are coming from. That's all your EFM data that's coming out of ACM.
Okay.
Yeah.
That's phenomenal. Yeah, it really seems like, I mean, the more we're diving into it, it really seems like there's multiple use case applications, which this kind of alludes exactly what I was talking about at the beginning of the call. There's so many different components to this overall network. ACM is basically helping manage the flow and control of where data is going, how much data, how quickly is it getting there, what protocol is it actually using. Um, in both applications, so it is kind of a mixture of both. And this is probably more realistic for the vast majority of y'all's customer base, right?
Yeah,
Mhm.
yeah, it is. And, but I do want to reinforce that the main reason, and why, again, why we talked to Tosi and we're collaborating is that everyone's trying to do their own thing. And it's the collaboration between the internal customers and I'll say SCADA, historian, OT cybersecurity, measurement folks, all the groups that want to go out to the edge and they want to keep those devices safe. They need to route things properly, et cetera. And instead of everyone having an individual device and going it alone, what you can do is we're seeing this consolidation. Use edge compute as bridging that gap. So, you could lay down a cybersecurity container if you needed to. You can push those different models. Every group can start to share in that data and that workload, in device consolidation of software and hardware out in the field. Because the more you have out there, the more you got to support. And edge computing has allowed us to be, you can standardize on a hardware platform, or necessarily not painted into it needs to be a specific device because it can be vanilla. I can choose an Emerson, I can choose an Advantech, I can choose a Moxa, and I can lay these pieces of software down based on what the site capability needs to be and your requirements and such.
Yeah. Um, a question on the SCADA side of everything. I mean, I run into it a lot with the upstream space is the one that to me is the most because there's a lot more acquisitions that go on a regular basis. And so it's the most we acquired this and it's using this SCADA system. And then we acquired this field that's using this one. And we do want to merge them all into one, but we still need these to run at the same time simultaneously. And Tosi Box has really found a niche in that space of being able to, you know, segment that data traffic, whether you have an edge node at every field location at this new acquisition, and you want to cipher that traffic to go to that SCADA system as well as to the main one that you're trying to merge everything into. I guess my question really is in the AutoSol space, on different SCADA systems, is there really anything different that you're having to do to integrate with, a ZD SCADA versus a ZI versus, an XSPOC, which is a little bit different space, but or an ignition or anything.
I'll let Cody answer the technical part of that, but from what I see, no. We allow it to be vanilla. You don't have to paint yourself into a corner of it needs to be specific SCADA or specific this. That's why we're a very open platform and we're sitting in the middle because you could decouple or couple things very quickly. But I'll let Cody answer the technical part of that.
Yeah, that's 100% right. When we convert protocols, it's usually from something that's proprietary. So if you have a field full of Emerson RTUs out there, or a field full of SCADA packs or ABBs, you can bring all of those into AUTOSOL ACM, and then we make it available via a standard interface, OPC-DA, OPC-UA, or even MQTT, which all of these HMIs that we're feeding, or external historians, they all speak these common interfaces, usually via OPC-DA or OPC-UA, so they can connect directly. Breaking out the polling part from where you're actually doing your SCADA is one of the benefits that you get from ACM, because then it lets you, if you do have to move or merge 4 or 5 different SCADA systems together, you have your communications layer that doesn't have to change when you go from one to the other.
Awesome. Okay. I do have another question on, we talk a lot about the oil and gas space because that's actually where I know Andrew from, and I know you from as well, is from working on that side of the house. But Tosi Box as a whole, we're in every vertical imaginable, every different type of application, from traffic control to building automation to water and wastewater. And I know some of the people that are on the call are in completely different fields. We're all, as AUTOSOL, been deployed. And do you work in the water and wastewater space? Which this will actually bring me to another question. Do you have any BACnet capability using BACnet protocol, like for the building automation space?
Yeah, so we don't currently support the BACnet driver, although it is on our roadmap to add that into our protocol, or into our protocol engine, ACM and Edge ACM. But yeah, currently we are used mostly in oil and gas, and that's partly due to our capability to collect EFM data. It's kind of where we specialized. So we've gotten a big foothold in that industry. But we do have some use in water, wastewater, and building automation, and some other verticals like that.
Okay, awesome. Well, I guess this kind of will bring up the next slide real quick, if I'm not mistaken.
Yeah, so this kind of shows how ACM works. You connect to your devices out in the field. ACM gets the data from usually somewhere on your server side or private cloud infrastructure. And then from there, distributes the data to wherever you need it. We can publish your EFM data in several different formats, send it directly to FlowCal, to the transaction queue, CFX files, send it to historians, leak detection systems, or even your HMIs.
Can you do API callouts from ACM if it's in the cloud, like connect it without having to actually set it in the same hosted environment as a customer's, if everything's hosted in AWS for them, but they have some applications, Snowflake's a good example. Snowflake, maybe they're using Snowflake. Can you tie into Snowflake? Or is there a way, I'm assuming maybe you could use IoT Bridge or something of that nature, but
Yeah, you could use something like that. We don't have a direct injector for Snowflake right now. But yeah, you could use something like that to get data from ACM into Snowflake.
okay, awesome.
And this slide shows the same thing, but for Edge ACM, which is going to be sitting on the edge, collecting that data. And then it sends it to a broker, which allows, I guess, a bit more of that hub and spoke model, but sending it out to all the same places. And then I think Snowflake can connect directly to an MQTT broker and get the data that way.
Yeah.
You press the button with the animation.
Oh.
Yeah.
There we go. Yeah, we're actually in the middle. This is what I've been working with. Velasco.
Josh. Yeah.
Yes, with Josh Velasco on testing this with a broker, an MQTT broker in our Tosi cloud environment. a little preliminary testing on ACM, EACM running on a same hardware as the Tosi, and then also running on an edge compute node behind a Tosi box, trying both scenarios and seeing that data being able to pipe through a Tosi box VPN to an MQTT broker, and then from there be utilized in something like an ignition application. This all just so everyone knows that is watching this. This is being recorded, so you'll be able to get a copy of this as well. But if you have any questions that come up, please feel free to type them into the chat, and we'll do our best to get those answered before we wrap up. But I did kind of want to end on this slide for the AUTOSOL portion of this conversation, and really, Andrew, I think where we first met was at an Intellect conference in West Texas, actually. And the first part that came up is we were looking at edge compute.
Yeah,
Why do you think there's been such a shift to computing at the edge? And is it really, it seems like every company I've talked to is trying to figure out how to implement computing at the edge into their overall architecture.
I mean, it's being thrown around like a buzzword, like, oh, we need to do edge. And the first question when people say, oh, we're interested in edge, I'm like, okay, well, why? What do you have? What does your communications infrastructure look like? What are you trying to talk to? What can you leverage? What is the business related outcome that you're trying to do? And so it comes down to maybe it's starting off as a OT cybersecurity thing. I need to go put in an appliance at each of these sites. Well, again, you can start to use that edge compute plate for this. So I'll just use my analogy, which I've used a million times, is that traditionally, if edge computing and the software and everything was a meal, people were picking an $80 piece of filet, which is the expensive software to do something, and they were putting that on a paper plate and they're giving you a plastic spork to eat it with. That's not going to give you a good experience in having that meal. So look at edge compute as it's that robust plate. How big or small and how many things I can put on that plate, that's what would determine the size. And then also the knife and fork, you need to think about edge orchestration. Day one deployment, how am I going to do this in a scalable fashion? And then once I get over 5 boxes in the field, let's say I have 100 or 1,000, how am I going to manage those without sending somewhat, a field tech out with a USB drive and a 100-foot Cat5 cable to go reprogram stuff? So it started off as, hey, I want to do some edge polling, but again, hey, let's bring the OT cybersecurity folks in here. Let's bring what those unit owners are, and what are their requirements, because maybe there's 3 or 4 things you can put on a box. And I will leave it with this because I know we're running short on time. That when you're choosing it, don't go on Amazon and get a $60 Raspberry Pi and think you're going to do 10,000 tags off of it and put it out in West Texas. It's not, you're not going to be happy and replace them all the time. So our MVP is a 4-core ARM, 4 gigs of RAM, and then 64 gigs of storage. That allows you to run other like AUTOSOL and Node-RED and Tosi box very effectively, but also gives you room to deploy other containers when you see fit. So you only need to touch the site once, because truck rolls are expensive. Let's just say they're $3,000 a pop. I used to be paid to go out, or had rolled my guys to go out to a site 4 or 5 times. Well, every time if they're doing one thing or they're doing 10 things, that's $3,000 for them to get out there. So I'd rather only send them once, and then once you have the connectivity, you can manage that box, compared to, oh, go do another thing, oh, go do another thing, oh, go do another thing. And we're seeing a lot in these efficiencies. And then bringing an MQTT data in, or high res data, 1 second data, we'll just call it that, is allowed to feed these models to get this high res data, so they can start looking at machine learning, or looking at these models that they can push down to see where optimization is and what they're doing in a lightweight manner.
Awesome. Well, that kind of brings us, what I'll tie up with a little bow here is actually the 2 types of applications that Andrew and Cody and I have gotten into, where Tosi box and AUTOSOL as of this point in time. There's some cool stuff that we're working on in the background, but as of this point in time, where we really fit is if you have a pre-existing Tosi box infrastructure is exactly what Andrew was just talking about, is finding if edge is something that you're really looking into. I definitely encourage you to reach out to Andrew and Cody to have that discussion on, especially if you're wanting to do protocol conversion at the edge, if you're having comms loss issues at different sites, and that data is critical to have in your system, is the capability of storing forward using just throwing EACM in an edge compute device to be able to do that, as well as convert that protocol to something like MQTT. That I can't tell you how many times we look at a cellular bill from Verizon for a customer and it's $12,000, and they're using a ton of data on a minimal amount of actual data that's required, and it's because of how quickly and how constantly they're polling this data. Moving to something like an MQTT protocol, to where it's literally a public subscribe protocol that you're setting the standards of. I only want a notification if something changes. And if it changes by this much of a parameter, if it changes by 0.1 degree, that's not an issue for me. I don't need to know that. If it changes by 0.5, okay, then I would like to know. Um, but the two ways that we've actually been able to work together is, one is utilizing our lock for container on the same hardware as EACM. And in this image itself with Node-RED, EACM, and the Tosi box lock for container, which still gives you remote accessibility through multi-factor authentication. It still gives you the same levels of VPN encryption. It just doesn't have the firewall, because the firewall is part of the hardware. Or if you have an existing infrastructure, finding that type of edge compute device that you can load some of these applications, or an application like EACM on. But with that, guys, the last piece that I'll note, and then if there are any questions, I'll stay on for a couple extra minutes. But we do have our next webinar in the series coming up on October 14th, and this will be with inductive automation. So ignition, they're going to come on and talk about ignition, talk about the use cases that they've seen, where they're growing into. They just had ICC last week. Andrew and Cody just got back from it. This was the first one that was actually in Sacramento this time, and it was a lot bigger from what I've heard than the last few years. But they also just released Ignition 8.3. And there are a lot of new features that come out in that. And so we're going to bring them in on the webinar series to kind of tell everyone what Ignition is, talk about what the features are, talk about what developments they have. But with that, I guess if there is anything else, any other final points or comments that y'all would want to make.
Nope. We're just, happy to help. And people are redoing their network architecture, and there's a lot of pieces to the puzzle. And so through between AUTOSOL and Tosi box, we have a lot of expertise to help navigate through these, not tell you, oh, do exactly this thing, but to listen to your use cases and give you recommendations of, hey, here's option A and option B. Here's how you can do those things to, increase efficiency, save money, make more money, etc.
Yeah. Awesome. Well, guys, I really appreciate you joining and hopping on and kind of having this conversation, for sure. I always learn a lot whenever I talk to the two of you.
Great. Thanks, DJ.
Thanks for having us, DJ.
Thanks, everybody.
Thanks, guys.
Take care.